And there we go. Okay, so guys, you'll notice that I even changed the title of your notes today. I don't think you need to do that, but what I found was we're really not just going to learn about lab procedures. There's also some techniques and concepts that we're going to include today as well. And then if you look at the second slide that I gave you a laundry list of everything that you were going to learn to do. And you'll notice there's even YouTube links embedded in that. We used to teach this material by showing you YouTube videos. I've decided that I'm not going to do that. I didn't love it. Frankly, I did it out of respect for a person that I taught with a couple years ago. Not Mr. Hart, it was someone before that. They've left, and I decided I don't like the YouTube video approach. Bless you. So we're not going to do it. So guys, instead of YouTube videos, I'm going to show you everything we're going to go over. Now, if you need refreshers on this, you've got the YouTube links and you can go look at them, but I don't think we're going to need those. Okay, so now guys, go into page 2. This is the first thing that we're going to talk about. So here's the big idea as we chunk this together. So guys, when you go over into lab on Friday, and I should mention this. I see a couple of you have your goggles. At the end of class today, you will have some time to work on homework. If you want to go put your goggles in your drawer, I can give you a Sharpie, you can do that. Understand guys, if you don't have goggles here by Tuesday, you won't do the lab. Okay? You've got to have your goggles here on Tuesday. Okay, so guys, the first thing we need to talk about, and this isn't in your notes, but that's fine, is some skills. And the first skill that you've got to have in lab is the ability to light one of these things, which is called a Bunsen burner. So guys, this is a Bunsen burner. I think most of you probably noticed these were sitting on your lab counter when you went over into lab. But guys, what I'd like to do is I'd like to explain to you the way a Bunsen burner works. You will never do what I'm about to do, but let me just show you because it's helpful. So guys, these Bunsen burners actually are composed of 3 parts. You'll never do this, but it's good to understand. So guys, here's the way this works. A Bunsen burner has got a base, a needle valve, and a barrel. And the way that this works is when this Bunsen burner is hooked up, it's hooked up to a natural gas tap. The gas comes through the hose. I feel like a stewardess on an airplane. In the case of decreasing cabin pressure, yeah, anyway. So, I don't know why I thought of that. But guys, so that when it's hooked up, the gas will come in the side, and then it makes a right-hand turn, and it goes straight up. And when it goes straight up, it goes through this itty-bitty little hole that we call a jet. And when it goes through that jet, it's just like water going through a constriction in a garden hose. It comes out like a rocket. And as it comes out of there, it then goes up the barrel, and then you light it on fire. So guys, with that in mind, actually, let's do this first. Let's talk about this needle valve. You'll notice at the tip of this needle valve, there's a very fine point. That fine point fits in the jet and clogs it. So if you screw this in from the bottom, if you screw it all the way all the way up, now the needle is in the hole and gas can't get through. Get the idea? Okay. Then guys, the barrel. And you'll notice that this barrel has got these slits around the bottom of the barrel. For those of you that understand how this works, that's like a carburetor in a lawnmower or something like that, because our cars don't have carburetors anymore. So the way that this works is when the gas comes in, it goes this way, then it goes up the barrel really fast. As it goes up the barrel really fast, it draws in air through these vents. The air and the gas mix inside the barrel, and then it burns up here. Okay, so guys, with that in mind, let me explain to you, and you've got this in your notes, let me explain to you how to light a Bunsen burner. So guys, it goes like this. The first thing you're going to do is you're going to shut down the burner, and you've got this in your notes. What does that mean? And guys, don't be afraid to handle these. Pick them up. And so the first thing you're going to do is you're going to screw the needle jet all the way closed. Then you're going to screw the barrel all the way down. You're going to close this thing. Then guys, after that, the next thing that you're going to do is you're going to turn on the gas. Exactly, that's the point, David. So let me show you. So Guys, this is the way these gas taps work. Let me show you. So you've got a nozzle and you've got a handle. In your lab, the nozzle's horizontal and the handle goes this way, but it doesn't matter. The deal is this. Anytime the handle is perpendicular to the nozzle, it's shut off. Anytime they're lined up, it's on. So this is off, and that's on, and we're now filling the room with natural gas. Okay, so yours will already be connected. I disconnected mine. But now what you're going to do is you're going to turn on the gas. And as David pointed out, there is no gas flowing out of the burner. Why not? The valve's closed, right? The needle valve is closed. So now step 3, you're going to open the needle valve. And guys, you're going to be able to hear this. Listen. Can you hear the gas flow? As soon as you hear the gas flow, give it about another quarter turn and you're good. In lab, when it's loud, you may not be able to hear it, so you can always stick it in your ear and you'll be able to hear the gas flow. Now guys, I'm going to shut this off for a second because we'll fill the room with gas and I don't want to do that. So what do you do after this? Well guys, step 4 is light the burner, and then step 5 is adjust the flame. And the deal is this. You adjust the height using the valve and you adjust the heat using the barrel. So here's how this goes. Kind of like campfire. Okay. So guys, in order to do this, we don't use matches to light our burners because then you throw matches in the trash and we have trash can fires. Instead, we use this, which is called a striker.
Teachers, please stand. The students with the last name that starts.
So guys, here's the way this works. In order to get this striker to work, you're going to sit here and do this until your hand cramps up and you're never going to get this to spark. And then you're going to remember the tricks that I showed you and you're going to go like this and this thing sparks like crazy. So guys, how do you get this thing to spark? You ready? Here's the trick. You need a gun. And it's got to be a left-handed gun and it's got to be a gangsta gun. Okay? Seriously. So just, you'll remember this. Just think gangsta gun, but it's got to be left-handed. And what you're going to do is you're going to put the hood of the striker against the barrel of your gangster gun, and then you're going to hook your thumb, the hammer, on this leg of the striker, and you're going to squeeze until it puts a dent in your thumb. So left-handed gangster gun, put it here, squeeze, and then when you go like this, what you're doing is you're taking this piece of flint and you're driving it into this rough part, and then it'll strike and you'll get sparks. Okay, again, if you do this, it's never going to spark. So, guys, again, gas is turned on. We've already opened this up. We come along here and we just lit the Bunsen burner. For some of you, getting this Bunsen burner lit is going to be a major victory on Friday. It's actually fun for me to walk around and watch you guys struggle. I know that's bad, but it is. So, guys, so Bunsen burner, right? And we've got the Bunsen burner lit, but here's the problem. Guys, this is a wildly inefficient flame. We will never get chemicals to heat. We will never get water to boil with this Bunsen burner flame. What we've got to do is we've got to make it more efficient. So how do we do that? Well, guys, this is the flame that we're shooting for. When we've got this right, this is what we want this to look like. Notice that you've got a sharp inner blue flame and a taller outer blue flame. And guys, right here is the hottest part of that flame. So how do we turn this nightmare into that? Guys, the answer is this. The first thing you're going to do is make it shorter. We want to bring it down. So how are we going to do that? The valve. So we're going to come down here and we're going to screw this in until the flame, what is that, maybe 5 or 6 inches? About like that. You want the flame to be about 5 or 6 inches tall. Once you've done that, now we need to adjust the heat by changing the barrel. And guys, don't, I'm okay. Guys, don't do this by grabbing the top of the barrel. This is hot. Grab the bottom of the barrel and watch what happens. When you grab the bottom of the barrel, and you may have to grab it and turn it first, as you open this up, look what happens to the flame. Why did the flame just change? What did turning the barrel do? Opened the vents. And as we open the vents, it is now drawing air up into the gas, and they mix and they burn more efficiently at the top. So now, guys, we need to fine tune this. So this is a little too short. So what do? Hey. So this is a little too short, so we're going to add more gas. And now we're going to add a little more air. And guys, that is the flame that you're looking for. You can hear it roar. If you can't hear it roar, you're not where you need to be. Does that make sense? Okay. Then, guys, when you're all done with this, the last thing you need to do is you need to shut the Bunsen burner off. So how are you going to do that? Well, guys, do not shut the Bunsen burner off at the burner. That actually will leak. So to shut it off, just go right there. You guys good? Bunsen burner 101. When you struggle with this on Friday, I'll come and help you. We'll get through it. Okay. Yeah, and then you're done. When you're done, you're done. Just leave it like that and you're good. Yep. And then the next group that comes along, they'll close this, they'll shut this down, and they'll go from there. Yep. You guys okay, Bunsen burners? Questions? Okay. So guys, the next thing that you need to learn how to do is you need to learn how to use a balance. And you'll notice, I think this is in your notes. Let's make sure. Do you have this thing about never put chemicals on the balance and use the tare button? Guys, you may want to underline use the tare button. That's going to be important. So guys, here's the trick. These balances that you will have at your lab stations are actually pretty good. They're about $300, $350 balances. It's these guys. You need to figure out how to use these things well. And this is actually this, so let me explain this to you. Guys, you will never need this button over here that says print in units, because we will always measure in grams, units, and we don't have these hooked to printers. But you will need this button over here that says on and re-zero and off. And guys, when this says re-zero, technically that is what's called the tare button. And you may want to write this down, or at least mess up your notes so this makes sense. Tare just means re-zero. So where it says re-zero right next to that, you may want to circle that. So you remember that tare means re-zero. And guys, here's the bottom line rule. Anytime you approach a balance, hit re-zero. Just get used to that. Every time you walk up here, just go boom, re-zero. Just get used to re-zeroing a balance. So guys, in lab on Friday, what you're going to be doing is you're actually going to be using the balance to figure out the mass of some salt and some other things, but salt first. And so guys, what you're going to see in lab is you're going to need a gram of salt. So guys, first rule is this: when you come and get your vial of salt, you're not going to dump it on the balance. The reason is because some of these chemicals can corrode the pan of the balance. So instead of that, we're going to use one of these, which is called a weighing boat. So guys, check this out. This is pretty slick, sorry. So if you want to get a gram of salt, the first thing that you're going to do is you're going to put the weighing boat on the balance. Now guys, the weighing boat weighs 2.18 grams. But we don't really care because we don't want to know the weighing boat. We want to know the salt. So guess what we're going to do? We're going to hit the re-zero button again. And what that functionally does is subtracts out the mass of the weighing boat, and now it says 0. Get the idea? So now what we're going to do is this. We're going to come along, and guys, this is what is called the tap method. What you're going to do is you're just going to tap on this, and you are going to get a gram of salt. Now here's the trick. You're going to screw this up like I just did. Guys, I just got 1.31 grams of salt. I got too much. So what am I going to do? Well, guys, let me explain to you what you're not going to do. What you're not going to do, and by the way, if you bend these, they turn into a funnel. What you're not going to do is take this and pour back into here. Why not? This is contaminated. Guys, you don't know what happened to this weighing boat. And if there's contaminants in this weighing boat, and if you pour it back into here, you just contaminated everybody else's sample. So guys, bottom line is this, and if you can't remember this, write this down in your notes. Never pour back. Guys, never pour back into a stock container. You will never do that. So just a second. Oh my gosh. All right, so if you never pour back into a stock container, then guys, what are you going to do if you get too much? And guys, this is the answer. What you're going to do is you're going to take your spoon and you are going to scoop some of this out of your weighing boat and then put it back. And guess what? Now it weighs less than a gram. Then what you're going to do is you're going to carefully go up to a gram, and now that it weighs a gram, you've got the extra stuff right here. What are you going to do with this? Throw it in the trash. Get the idea? Guys, never put stuff back into a stock container. And so if you get too much, take out some of the excess with your spoon, get it up to a gram, and then throw out the extras. Get the idea? Okay, now guys, here's the trick, and I obviously just put that back in the weighing boat, but now we need to talk. Now that this says exactly a gram, do we know that that actually weighs a gram? We don't. Guys, our balances are not necessarily accurate. That might weigh a gram, and it might not weigh a gram. So what did you learn from the homework today? What are the homework we just graded? What are we going to do to guarantee that that weighs a gram? We're going to do it by differences. We're going to weigh a beaker, then we're going to add the salt, then we're going to weigh the beaker and the salt. And by subtraction, we can figure out what that salt actually weighs. We'll talk about that more in a minute. Do you guys understand the tap method? Do you understand what to do if you get too much? You guys all okay? Okay. So guys, that's how to run a balance. So let me just get rid of this salt, and we'll go from there. So that's how to use a balance. Now let's talk about the next thing. Is this the next thing in your notes, graduated cylinder? Okay. So guys, when you are reading a volume from a graduated cylinder, there are some terms that you need to know and be aware of. One of those terms is the term meniscus. I don't know if you've ever had this experience, but when you put water in a cylinder, what you'll actually find is that the surface of the water is not flat. It's actually drawn up the sides of the cylinder because of capillary action. And so guys, that dip in the surface of the water is what is called the meniscus. So the question is, what do you do when you're measuring volumes relative to the meniscus? And guys, this isn't in your notes, so you want to write this down. You just need to write down the word bottom. You always measure from the bottom of the meniscus. And then guys, the other term that you need to understand is the term parallax. Parallax is error in measurement that is caused by misalignment. So guys, let's do this. Let's actually, rather than look at my graduated cylinder that none of you can see, let's look at this one and let's figure out the volume of the water. So guys, first of all, let's talk about parallax. If I want to measure the volume of the water, and I'll do this with my cylinder, if I want to measure the volume of this water, what's wrong with me doing this? I'm going this way, and my measurement's going to be too low. This way, my measurement's going to be too high. So what do I need to do when I make this measurement? Yeah, you have two choices. You can either drop U or you can drop this. I recommend doing both. What I would do is I would never make a measurement holding the cylinder. Put it on a countertop, and then guys, drop your butt so that you're level with this, and then you can make the measurement accurately. That's called avoiding parallax. Now, once you've done that, we've got to figure out what measurement we're going to take. So guys, as we look at this, and I'll go red because that'll stand out. As we look at this, can you see that slight dip that we call the meniscus? Okay, so where are we going to measure relative to the meniscus? And the answer is we are going to measure from the bottom of the meniscus. Now here's the question. What data are we going to write down from this volume measurement? Well guys, here's 40 and here's 50. So what does each one of those lines represent? 1 milliliter. Guys, listen. If each one of these lines is 1 milliliter, what are we going to estimate to? Tenths. Remember? we estimate 1 decimal place past the accuracy of the scale. So if the scale is milliliters, we will estimate to tenths of a milliliter. So guys, this is 40, 41, 42, 43, 44, 45. So it's somewhere in between 44 and 45. So if you wrote down this as your measurement, that's wrong. And if you wrote down this as your measurement, that is also wrong because you didn't estimate 1 decimal place past the accuracy of the device. So now guys, we've got to figure out what we're going to write down. So let me get this out of the way. And what do you think? 44.5, 6, maybe even 7. Guys, which one of those is right? All of them, because you're estimating. So guys, when you estimate 1 decimal place past, I would probably go like 45.6. But guys, that's what it means to estimate 1 decimal place past the accuracy of the device. You get the idea? Is that okay? All right. So guys, we are now done with how to light a Bunsen burner, how to read a balance, and how to read a graduated cylinder. Now your notes are about to get out of order. So page back to the one that says filtering. You see it there? Guys, another skill that you're going to need to have for this day is you're going to need to know how to run a filter. So guys, you've got the instructions in front of you. What does this go through? 6? Is there a number 7? No. Okay, so it goes through 6. Did you find the filtering page? Yeah. You're okay? Okay. So guys, here's the way this goes. In lab on Friday, you're actually going to be using a filter to separate solids from each other, well, a solid from a solution. Here's the way this goes. Filter paper, which comes in boxes that look like this, are actually flat, and you need to turn them into a cone. Here's how you do it. Step number 1 is fold this thing in half. This is kind of like in kindergarten where you made snowflakes. Number 2 is you fold it in half again. What you've now done is made a 2-dimensional cone. Now we've got to make this 3-dimensional. So guys, if you look at this from the end, you'll notice that you've created 4 pleats. What you don't want to do is stick your finger between 2 and 3 because then it just unfolds. What you want to do is you want to stick your finger between the first and second pleats. Doesn't matter top or bottom, but stick your finger between pleats 1 and 2, and then you'll see that you've actually created a cone. Now the thing that's nice is that this cone fits perfectly in your funnels. But here's the problem, and I know you can't see this, but the problem is that the way that this fits into your funnel, this corner right here, the corner that kind of folds around, this corner creates a bulge that keeps this thing from fitting tight to the funnel. And so in step number 4, it says clip the corner. So here's what you do. This flappy part right here, rip the corner off, and then it will fit perfectly flat to your funnel like so. But now here's the problem. When you let go of this, it comes out. So what are you going to do? You're going to get it wet. So guys, what you want to do is put this in here, and then you're just going to come over here to your sink, put a little water in it. Now it sticks to the funnel, and you're good to go. Does that make sense? So guys, again, you'll be doing that on Friday. We good? Okay, so guys, we now have talked about 4 things. You know how to light a Bunsen burner, you know how to run a balance, you know how to read a graduated cylinder, and you know how to filter. Questions there? Okay. So now guys, what we need to do, now that you understand these skills, we need to now talk about some techniques. Now guys, what we're going to do first is we're going to go, and again, we're skipping around a little bit, go to the page that says dispensing liquids. Oh, that's right above the filtering page. Again, we're jumping a little bit. So guys, in lab, you are going to need to be able to pour liquids. Let me sort of clean up my mess here so that we don't have quite as much of a problem. Okay, so guys, in lab, you're going to need to learn to pour liquids, dispense liquids. And guys, it's really important that you do this properly. So the first thing we're going to talk about is what is simply called pouring liquids. And when you do, there are some things that you need to keep in mind. This is important. You may want to underline this. Does it say it just like that? Yeah. Guys, underline the word palm it. Bless you. This is important. Then, guys, and we'll talk about in a minute, the second thing that you need to remember is never pour back into the stock bottles. And the third thing is always return lids when you're done. So, guys, here's the way this goes. Imagine that you walk into a lab, and this is just water, but imagine that you walk into lab and the lab says, go get 25 milliliters of water, okay? So you need 25 milliliters of water, and so you come into the stock, you come up to the front of the room and you find the bottle that says water, and you know that you need 25 milliliters of water. So the first question is this, and this isn't in your notes, you're going to want to write this down. Guys, how are you going to measure 25 milliliters of water? What device will you use? You just learned. Graduated cylinder. Guys, do not ever use a beaker. Yeah, on the beaker, there's a line that says 25 milliliters, but these are not accurate. So you're going to want to write, actually, I'm going to just add this to the notes. Always graduated cylinder. All right, there we go. So you're always going to use a graduated cylinder. So guys, imagine this is how this goes down, and you come into lab, and you grab your bottle. Again, it's just water, so I don't need goggles. And you're like, hey, yo, and you come here, and you pour this up, and you're like, oh, poop, I got too much. So you never pour back in, right? So what are you going to do? You're going to come over here. If it's not dangerous, you'll pour it down the drain. If it is dangerous, you'll put it in a container. And you get this, and you get this down to 25. And all right, I got my 25 milliliters. And you go back to lab, and you go do some chemistry. Well, guys, here's the problem. At the end of the day, we're going to end up with a scene that looks a lot like this. We're going to have bottles everywhere. We're going to have lids everywhere. And we've got a big old problem. The problem is that when we come back to clean this up, when you come back to clean this up, because I will never clean up after you, so when you come in here to clean this up, you don't know which lid goes with which bottle, and if we get these backwards, we contaminate our bottles. So what are we going to do? Guys, this is the way this goes down. In lab, you will never see a lid sitting on the counter. If you do, someone's in trouble. Here's the way this goes. Guys, when you grab a bottle, you screw the lid off the bottle and you palm the bottle lid in your dominant hand. Then what you will do is you will grab the bottle with the lid in your hand. You will then dispense whatever it is that you need, and then you will put the lid right back on the bottle, never having put the lid down. That way we never get the lids messed up with the bottles. Get the idea? That's what it means to palm the lids. Guys, never set lids down on the counter because we get them messed up and that causes problems. You guys good? Okay. So guys, what about this? That makes sense if we want 25 milliliters of something. Guys, what if we need only a milliliter? Just 1 milliliter? Because this graduated cylinder only goes down to 10. So what if we only need 1 milliliter? What are we going to do? Guys, let me show you. This is actually what is called transferring. Transferring involves a pipette. So guys, when we need to transfer, this is how this works. When we need small volumes, you will always find a transfer pipette stuck to the side of the bottle. And guys, this is just water. This is like a little mini graduated cylinder. It goes 0.25, 0.5, 0.75, and 1 milliliter. So if you need 1 milliliter of this liquid, here's how you do it. So guys, the first thing that you're going to do is screw the lid off the bottle and set it down. No, you're going to screw the lid off the bottle and you're going to put it in your palm. Then what you're going to do is you're going to grab the transfer pipette that's attached to that bottle and you're going to stick it in here. Now you're going, wait, doesn't that contaminate the liquid? Why doesn't it contaminate the liquid? Because that's the only place this pipette's ever been. It lives with this bottle, so it's only been in here, so it won't contaminate anything. Now here's what you do. You squeeze the bulb of the pipette, you stick it in here, and then you let go. And what that does is it slurps the entire bulb, well, not the entire bulb, but it slurps liquid all the way up into the bulb. Then what you do is you drip back down until the meniscus, because you'll get a meniscus here too, until the meniscus is sitting on the 1 milliliter line. Now I have exactly 1 milliliter. Then when I let go of the bulb, it sucks that milliliter of liquid up into the dropper and it contains it. Now I can screw the lid back on if I need, and I can dispense this wherever I need it. And then when you're done, all you got to do is put the dropper back with the bottle and we'll never get contamination. Good? So transferring and pouring. You guys good on those two? Okay, so now guys, the next thing we need to do, and I think this is out of order in your notes, we got to talk about fixing our balances. It says dispensing and weighing solids. So guys, here's the trick. We all were, did you find it? Where's it at? So it's page 6. Okay. So guys, here's the trick. We understand that our balances don't work, right? Well, that's not true. Our balances are not accurate. When we weigh something on this balance, it may not be correct. But we need to know what things weigh. So how do we do that? And guys, the answer is what is called weighing by difference. So with these ideas that we already understand, that we're avoiding contamination, never putting substances on the balance, and we'll use this TAP method. Guys, what we're going to do is we are going to do what is called weighing by difference. So guys, and you've got the data chart. I think you have the data chart in front of you, don't you? So guys, this is what you're going to do in lab when you need a gram of salt. So guys, the first thing that you're going to do is you're going to weigh out what you believe to be a gram of salt. So here's what you're going to do. You're going to take a weighing boat, you're going to put it on the balance, and then what do you do next? Hit re-zero, hit tare. So now we've got rid of the mass of the weighing boat, and it says 0 again. Then what we're going to do, using the TAP method, is we're going to take this up to a gram. What if you get too much? Never put it back. Get your spoon, pick out the extras, and then get it to exactly a gram. And then when you get it to exactly a gram, you can throw out the rest. Okay, so there's a gram. But now guys, here's the trick. Does that really weigh a gram? We don't know. The balance could be off. So guys, how do we fix that? And this is the answer. Guys, what we're going to do is this, and write these numbers down with me in your notes. You've got this in front of you. So what we're going to do now is this, and guys, watch what happened. Now I have the salt and the weighing boat on here, right? Guys, when I pull this off, what do you think this display reads? A negative mass. Because we already subtracted out the weighing boat. So what I'm going to do is I'm going to re-zero this again, and I am going to weigh the beaker. And the beaker weighs 33.15 grams. Write it down. 33.15 grams. 1.5. Now guys, what am I going to do? I'm going to add the salt. I believe that this is a gram. I'm going to add it. And now this weighs, and by the way guys, the other thing you'll notice, there's some salt still in the boat. Let me tap that in. And now this weighs 34.20 grams. Did that salt actually weigh a gram? No. We'll talk about how to figure out what the salt actually did weigh in a minute. But guys, that's what we're going to do is when we make these mass measurements, we're actually going to weigh by differences because that gives us better data. You get the idea? Okay, and well, actually, hold on a second. Let me see how I restructured this. No, we're good. Okay, so you guys good on that idea? Yes, ma'am. Wow, thank you. I forgot to mention that. Tell me what you're thinking with 150. Estimate one place past the accuracy of the device. Guys, please hear this. This is going to be on the test. I'm so glad you mentioned that. Guys, let me say this differently. When do you estimate one decimal place? You estimate one decimal place when you are comparing against a scale, like here and on a thermometer. When you're reading a digital readout, you don't have anything to compare to. You don't know if it's a little bit above 0.15 or a lot above 0.15, so you don't estimate with digital displays. Does that make sense? Okay. All right. So guys, you good on this about how to make these mass measurements? Okay. So now guys, we're going to move on, and we are now going to talk about concepts and calculations. This is not in your notes. Well, some of it is. Well, this isn't, but some of this material will be. So guys, when we talk about concepts and calculations, we are now going to analyze your data. So, can I see? You guys are now on, I think this is in here, 10? Yes, good. You are now on page 10. So guys, here's the question that we're going to answer. And I'm going to leave it like this. So guys, the idea is this. We understand that our balances are not necessarily accurate. They're wonderfully precise. If you put something on there once and then do it again and do it again, you'll get the same number. But guys, they're not necessarily accurate. So how do we guarantee accuracy? We weigh by difference, which is what we just did. We have the mass of the beaker. We have the mass of the beaker and the salt. Here's now the question. How do we find the mass of the salt? Well, we subtract. But guys, how do we represent that? Did I show you? I did. So guys, this is critical. This is what you're going to do in lab. In order to find the mass of the salt, you're going to set it up like this. You're going to go mass of the beaker, you can abbreviate, plus the salt. So we've got that, right? And then from that, you're going to subtract the mass of the beaker, and that results in the mass of the salt, and we know that that will be accurate. So guys, you feed me the numbers. What was the mass of the beaker and the salt? 30 what? 33.20? Really? No, we need beaker and the salt. Oh, good. Okay, hold on. Let me clean this up. Tell me again. 34. Thank you. 34.20 grams, and then the mass of the beaker itself was 33.15 grams. And then, guys, notice these are and do this with me. These are lined up in columns. They're neat and organized. And then, guys, when we pull the numbers down, we get 1.05 grams. And we know that that is the mass of the salt. For the same reason, from homework question number 3 today, we knew the mass of the sugar because the errors existed in both measurements. We know that that's the case here too. So guys, every time you weigh something in class, you will always do it by difference, and you will always represent it this way in columns, explaining what you're subtracting and then doing the math. You guys okay? Okay. How do you get what? You don't. So the trick is this. Your measurements never have to be perfect, but you always have to know perfectly what the measurement is. Does that make sense? So if you get a little bit more than 1 gram, that's fine. You just need to know what it actually is. You okay? Okay. All right. So guys, now that we're done with that, we now need to talk about some mathematical stuff. We need to talk about significant digits. So let's review. Guys, how many significant digits are in 34.20? 4. The 0 is significant. What about 33.15? 4. And then what about 1.05? 3. So guys, what we need to do now is we need to talk about significant digits and answers based upon the setups. So you need to find this page. Says significant digits in calculations. Is it number 12? Oh, it's right below. Perfect. So guys, here's the deal. When you are doing math in this class, you will always be rounding your answers to the right number of significant digits. So guys, let me give you the rules. When you are multiplying and dividing, you get as many significant digits in your answer as the least accurate number in your calculations. I'll show you what that means in a minute. So guys, when you're adding and subtracting, you do not keep track of significant digits, you keep track of decimal places. So did I give you the examples? Yeah. Okay, so I gave you that much. So guys, it goes like this. 125.50 grams. How many significant digits? 5. Now guys, we're going to multiply that by 2.3 grams. How many significant digits? 2. When you do this math, the answer is this. Write it down. The answer is 288.65. But that answer is incorrect. And here's why. Guys, how many significant digits in the top number? 5. How many significant digits in 2.3? 2. How many significant digits do you then get in your answer? 2. It's the fewest. So when you're doing multiplication and division, look at the numbers that you're working with. In this case, 5 digits and 2 digits, and you always round to the fewest. So we've got to round this number to 2 significant digits. So 1 and 2, and then the 8 rounds up. So this number to 2 significant digits would be 290 grams. Now guys, what if instead of multiplying and dividing, what if we're adding and subtracting? Well, here we go. Same numbers, only now we're subtracting instead of multiplying. So you can obviously do the subtraction. It's 123.20. But now guys, how many significant digits do you get in your answers? Doesn't matter. Significant digits don't count in adding and subtracting. What does count are decimal places. So here we've got 2 decimal places. Here we've got 1 decimal place. So how many do you get in your answer? 1 decimal place. So guys, that would simply be 123.2. All right, gang, we got one more thing to do and we're done. So we now understand how to handle significant digits and decimal places in math. You will be doing this in lab. You'll be doing subtractions and watching decimal places. Guys, the last thing we need to do is this. And this will be the last thing that you will do in lab on Friday. You will be calculating your percent error. Guys, percent error is actually a mathematical representation of how wrong you were. You want to have low percent errors. So guys, this is the way that this equation works. First of all, do you know what these vertical lines mean? Absolute zero. It just means never negative. So guys, the way this works is this. You are going to take the number that you measured, the number that you got experimentally. You're going to subtract from that the number that you should have got, the correct answer. Then you're going to divide that by the correct answer and multiply by 100. So guys, fundamentally, the way that this works is this part tells you how far off you were. Here's what you did get minus here's what you should have got. Then you divide by how much you should have got, and that tells you for how much you got wrong, what part of the bigger picture was that, and then you multiply by 100. So guys, you do not need to memorize this equation. I will give it to you. You never memorize equations in this class. I will give you the equation. You need to be able to manipulate it. And guys, let's just say this right now. Every time you use an equation in this class, you've got to write it down first. So guys, switching pages, let's solve one of these together. And we're done for the day. So it says this. You have this in your notes, right? Okay, so it says a chemist reacts sodium and chlorine together in a closed Pyrex container. He or she expects to produce 17.2 grams of product. If he only collects 13.85 grams of product, what is the percent error? So guys, those last 4 words tell you what you're solving for. What's the percent error? So now that you know you're solving for percent error, what do you do first? Write down the equation. Go ahead and do it in the space. So guys, the equation goes like this. Percent error is equal to measured minus accepted divided by accepted times 100. Aren't you glad I printed the notes for you? Okay. So guys, now that you've got that written down, we've got to figure out which is which. So it says they expected to produce 17.2 grams, but they only produced 13.85 grams. So guys, which one is our measured value? Which one did we get in lab, the 13 or the 17? The 13. So 13.85 grams is our measured or experimental value. That's actually how much we got. Now the accepted value is how much we should have got. And that would be the 17.20 grams. Then guys, you'll notice that we also divide by 17.20 grams. And then we multiply by 100. So now guys, we've got to talk about the math. Let's see if you learned anything. The first thing we're going to do is the subtraction. If you've got a calculator, you may want to run these numbers through. So we've got 13.85 minus 17.20. The answer is 3.35 grams. But guys, how many significant digits do we get in that subtraction? Doesn't matter. It's a subtraction. We're watching decimal places. So how many decimal places here? 2. How many decimal places there? 2. How many do you get in your answer? 2. So that subtraction would be 3.35 grams. Then that is still divided by 17.20 grams. Now we've got to do that math. And guys, just so you know, this number right here, 100, does not limit significant digits. It's perfect. It's just a conversion to a percentage. So don't look at the 100 when you're thinking significant digits. So guys, how many significant digits in 3.35? 3. How many in 17.20? 4. So how many do we get in our answers? The fewest, 3. So you're going to go 3.35 divided by 17.20. Multiply that by 100 and then round it to 3 significant digits, and the answer is 19.5%.